is
Can you see my screen?
Yes, we can.
Yeah, that is a summary of what we did last time. Guidelines for selection of appropriate measures, measure of central tendency. That is the summary. If people need it, they can take it. Otherwise, we want to look at measures of dispersion. That is what we want to look at today.
what I want my meat.
So last week we were looking at measures of central tendency, and we said in measures of central tendency, we look at the measure of the location or the part of the data where most of the items are found. Now, when we look at the measures of dispersion, it is the same as looking at the variability or the clustering of data around the middle of the set of data. For example, if we have data that has got 5 items and each data has a value of 16, 16, 16, 16, what can we say about that kind of data? If we have a set of data of 4 items and each one has 16, 16, 16, 16, what can we say about that kind of data? What will be the variability of that data or the dispersion of that data? Yes, Zamzam? Zamzam is not here. Let me look for people who are here. Anyango is here. Anyango Olo. Yes, yes, Anyango. What can we say about that data where you have 4 items and all of them have 16, 16, 16, 16 as their value. What can we say about that data? Okay, people are still thinking, or they have just logged in and gone away. So let's look at the parameters for measures of center of dispersion. The first one is the range. When we talk about the range, we talk about the difference between the highest and the lowest values in a set of data. That gives us the range. So if you have data, for example, this one here, can we write down that data? Can we see the data?
Yes.
Am I talking to myself or I'm talking to a class? If I am talking to myself, then I switch off my machine and
We are seeing.
We're in
Yes, yeah.
class, Dexter.
How we do?
okay, can we write down that set of data that I've just shown down there? It is here.
The 10, 12.
Is here. The data is here. Can we write it down? You
Yes.
want me to say whether it is the weight of babies? That cannot be the weight of babies. It can be the weight of mice in grams that are about 1 week and a half. So we can write that down. In that data, what is the difference between, what is the highest value?
$17.
16.
17 and the
17.
lowest value?
6.
6.
8. 6.
So our range there will be 17 minus 6, which is
11.
6 is 11.
17 minus 6, which is 11. That is our range. Now we have other types of range that include interquartile range, which includes data between the first and the third quartile, and therefore consists of 50% of the data. Now, remember when we were finishing or winding up the measures of central tendency, we talked about the quartile, and we said quartile are positional data divided into 4 positions. Of course, when we look at the quartile, we don't see the 4th position because we start from the first quartile, the second quartile, and the third quartile. And we say the second quartile is the same as what? I mean, second quartile is the same as what? Not third, second.
A half.
Percent.
A half
50%.
or median. We said the second quartile is the same as the median. So median, we also said, is a positional parameter. It's a positional parameter. It gives the position. It divides the position. It divides the set of data. So when we talk about interquartile range, we're talking about the first quartile, the second quartile, and the third quartile. And interquartile is the difference between the third quartile and the first quartile. That is the interquartile range. Then we have semi-interquartile range. That is a half of the interquartile range. So that is our first parameter, the range. The second parameter is the mean deviation. Mean deviation is not the same as mean. It is mean deviation. And so what is it? It is the absolute values of the deviation from the mean divided by the number of measurements of values in the data. Now, since in discussing dispersion, we normally have a parameter called an item called n-1. Many times students assume that everything under dispersion is n-1. No, we've said here that it is the absolute values of the deviations from the mean, divided by the number of measurements or values in the data. So that is not n-1, that is n. Have we put our finger on that data we have? Would like to work out
Yes.
that mean deviation. So let us go. We start by working out the mean. Can we work out the mean? Let's work out the mean. Summation of x sub I . What is our summation of x sub I?
122.
Is equals to 122. And our n is 12. So here we have 122 divided by 12. What do we get? Is it 12 or 10? Divided by 10.
10.
It's 10.
What do we
10.
get?
The values are 12. The values are 12 as
12.2.
much as 10. The values are 12. Starting from 5
Before I
to
tell you,
21.
they are not 10 more. They're 12.
They're 12.
Yes, N should be
Yes.
12.
So this is not what you have. I've given you something different from what you have.
Yes.
Let me see. That is
It's
what
12.
you have.
Where are you guys getting 12 from?
Let me remove this and we write what you have. Can I remove this because it looks different from what you have?
Yes.
I don't want to use something
5
different. Let's use what we have.
So you start from 6.
6, yes. 6, then
11. Hakuna 8. Or 6, 8.
8.
Yes.
then
10.
10,
10.
11.
11. 12.
12.
Pardon? After 11?
12.
12.
Then
13. 14.
14.
15.
Then, pardon?
15. 16.
15, 16. Then,
17.
pardon?
17.
17.
16.
And 16? I saw 16 somewhere.
There's 16 after 15.
16? How many 15s do you have?
17.
115.
115.
Yeah.
Yes.
So this is 16.
Yes.
And
After
this is 17.
17.
17.
Then what is our summation of x sub I?
Do the summation. Yeah, 122.
It is still 122.
122. Tuongeze.
122.
Yes.
I hope you are not taking the one for the previous data that I've removed.
It is 122.
122 divided by 10. What do we get?
12.2.
12.2.
It is 12.2. Now, we would like to find deviations from the mean. Deviations from the mean. Remember what we said up here? What did we say? Mean deviation is the absolute values of the
Absolute
deviation from the
value
mean. So we get deviations
divided
from
by
the
the
mean.
number of measurements.
So we shall be dividing x sub I by the mean. So 6, it's not dividing, subtracting
Subtracting.
the mean from each of the items. We subtract the mean from each of all those items. So can we subtract?
The first one is negative 6.2.
This is
Negative 6.2.
negative 6.2. Sorry. Minus 6.2. I was looking for my negative sign where I have thrown it. The second one?
Negative 4.2.
4.2. The next one?
Negative 2.2.
Negative 2.2. Next?
Negative 1.2.
1.2. Next?
The first one is
Negative
negative 6.2, not 6.6.
6.2. The next one?
Negative 0.2.
0.2. Next?
0.8.
0.8.
0.8 or 2?
0.8. Positive.
0.8.
0.8. Next?
1.8.
1.8.
0.8. Next?
2.8.
2.8. Next?
3.8.
4.8.
4.8.
4.8.
8. What is the total there?
Let's see.
Okay.
Yes, what is the total?
Zero.
The total there is 0.
Yeah.
Now, we would like to remove the signs from our set of data. Want to remove the signs there. And when we remove the signs, we are making that set of data to be absolute. When we remove the signs, we are making it absolute. So we have put those two lines before and after our set of data here. So when we remove the signs, we make it absolute. So we have 6.2, 4.2, sorry, 4.2, 2.2,
Mhm.
1.2, 0.2, 0.8, 0.8, 1.8, 2.8, 3.8, and 4.8. So we have made our data absolute by removing the sign. So we want to find the summation of our absolute data. What is our total there? When we remove the signs?
28.
28.
28. Right, now we can find our mean deviation. Our mean deviation is equal to 28 divided by 10.
Challenges.
What do we get?
2.8.
2.8 is our answer. Have we written up to there so that we now continue?
Yes, Mwalimu.
Let's go. Let me go to class and see whether people are there. I keep going to class.
Yeah.
with people
Yes, you can.
there. You are there.
Yes, we are there. We've got 2.8.
Yes, we are.
We are there.
73 out of 100.
We are there.
You are 73 out of 124. So where are the rest? Where have the rest gone to? Where is Nyongesa? Has he come?
I'm here.
Where are you? Sijakuona.
Niko hapa nimepata 2.8.
Ama umesign in as JT? These people were signing in my class with initials. Where is Margaret? Where is Margaret? Margaret, where are you? The class rep for public health. Or I'm not having public health here. Is anybody from public health?
Yes.
Yes, we are here.
Or they have come? And where is group A? I've had Nyongesa's group. Where is Hussein?
Yeah.
Where is Hussein? Ameachia Nyongesa kondoo. Nyongesa.
Yes,
Umeachiwa
we are
kondoo.
together with Hussein.
Or you are with him there?
Ameenda kuswali kidogo anakuja.
Wache tumungoje kwa sababu atatuombea. Right, let's continue. So that is 2.8, and we said it's 80 in grams, isn't it? I hope we said that. Now, what I'm going to say we have already seen here. It should be noted that if the signs of deviations are not eliminated, the value will always equal to 0. That is there. I have mentioned something here for grouped data, but of course, I don't usually give students grouped data. I don't give students grouped data for this unless I forget. Now, we move on to continue with our table. We square our deviations. Can we square our deviations? 6.2 squared
38.44.
38.44.
38.44. Next. 4.64.
17.64.
17.64. Na watu wengine walienda wapi? 2.2.
4.84.
4.84. Next.
1.44.
1.44. Sorry, 44. Next.
0.04.
0.0. 0.04.
Yes.
Yes.
Next.
0.64.
0.064.
0.064.
Yeah.
64.
No.
0.64.
0.64.
We lost you, please.
Somebody muted my mic. Somebody muted my mic. I'm talking to myself and nobody's hearing me. Yes, what is 1.8 squared?
3.24.
0.24.
3.24.
24. Next.
7.84.
7.84.
7.84.
7.84.
8.
That is for 2.8 squared.
Yes.
Yes.
What about 3.8?
14.44.
14.44.
4.8 squared.
23.04.
23.04.
0.04. What is the total?
111.6.
It is
111.6.
111.6.
111.6. Is that
Yes.
so?
Yes.
Good.
Yes, yes.
Now, next we want to look at the variance. We have done that, so we want to look at the variance. What is the variance? What we have here, let's go up. This one that we have here, summation of x sub I minus x bar squared is called the sum of squares. Can we continue writing under variance as our second, our third? That's our third. That is number 3. So the sum of square deviations from the mean is called the sum of squares, or SS. Many times the symbols SS are used. So summation of x sub I minus x bar squared, that is what we are calling the sum of squares. That is what we are calling the sum of squares. The average or the mean sum of squares is called the variance or the mean sum of squares. Now, variance for population is represented by the symbol sigma. That symbol sigma squared. Let me see whether they have sigma here. Sigma squared. Yeah, the sigma is there. So our sigma is here representing the variance for the population. And the best estimate of the population variance is the sample variance, which is represented by S squared. Are we together?
Yes.
Are we together?
Yes. Yes.
I'm
Yes.
checking to see whether we are together.
Yes, we are.
We are together, right?
Yes.
Good. We are together, that is good. So the symbols for the variance for population is sigma, and for sample is S squared. So sigma squared and S squared are the symbols that we use for variance. So we can find our variance here. We had 111, it was 111 point.
0.6.
111.6.
Yes.
111.6. 111.6. Divide by what is n minus 1?
N minus
9.
1 is 9.
9. What is our variance?
$12.4.
Our variance is 12.5. Is that correct?
Yes.
Eh?
Yes.
Well, 12.4 grams squared. So that is the gram squared. Who is making noise in the class? There's something making noise in the class. Somebody is making noise in the class. Is it Nyongeza? Nyongeza uko kazini? You are packing medicine for patients. Right, there's something here that we needs our attention. So the dividing of the sum of squares by n minus 1, which we are calling degrees of freedom. So n minus 1 is referred to as the degrees of freedom. And the reason why we are dividing by n minus 1 instead of n is to remove bias from the estimate. And if all observations are equal, then there is no variability and the variance is 0. You remember the question I asked you in the beginning? You remember it? Do you remember the question I asked in the beginning?
No, we can't remember.
The question I was saying, you have 4 items and one has 16, another one 16, another one 16, another one 16.
Yes.
Do you remember it?
Yes.
Yeah, the answer is here. If
Yes.
all
Yes.
the observations are equal, then there is no variability and the variance is 0. The variance will be 0. Actually, all the parameters for variability will read 0 because even when you want to check the range will also be 0. If you want to find the mean deviation will be 0. So when you look at our items here, have you seen our set of data? It starts from 6 to 17. So you can see that those items are far apart. From the mean, we have an item that is 6 units away. That is the highest. So if data was to start from 10, our variance and all the parameters will have values that will be smaller. But because when we subtract 10 from 17, we shall get 6. I mean, we shall get 7. But if we subtract 6 from 17, we get 11. That is what it means by variability. So if your mean is at the center, you are looking at how far the other items are located from the center. That is dispersion or variability. Now, we have said if all the items, yes? Yes? Is anybody who is asking to be excused? I thought so. Anybody with a question? I'm explaining about the variability using the example we have and the other example I gave at the beginning. Now, if we have items that are very far, then the variance will be high, and that's what I've said here. Variance becomes increasingly large as the amount of variability of dispersion increases. Can you hear me?
We are getting you.
Okay.
Yes, we are
The
getting you.
working formula or machine formula for calculating variance is this one. Now, this formula is what I put in the, is what I normally put in my exams. And so it's always important that I put it here and everybody sees it and we use it. So when we want to use this formula, then we don't use the simple one here. But many times students want to stick to the simple one. But there's something I want to show you. Have we seen that formula that I'm talking about? Allow me mute that microphone. That I don't know who is talking. Will I get the person talking? I've not seen the person talking. Wanted to mute. Kindly, if you want to talk to members of the family in the house, you can mute your microphone so that we don't listen to your conversation. Right, so I was explaining about the machine formula or working formula that I normally put in the exam, and we will use it with the example that is here. We have summation of x squared minus summation of x into bracket squared divided by n, the whole of it divided by n minus 1. Now, I would like us to go to the table so that we find where summation of x, the first summation of x, where it is. The first summation of x is this one here. There is x here, and this x here is derived from x sub I. So we don't calculate all that is here. We are in the exam and we are saying these things of the carry are too much. You want to go straight. So if you want to go straight, then you will square x sub I straight away. Can we square x sub I? 6 squared. You are calculating 6 squared.
36, 64, 64, 100.
Sorry. I'm writing there.
Wait, this one is
100. Next one.
121,
121 or 122?
144,
122.
1? Where are we? 12.
144.
There should be 144.
No, the first one is 121, not 122.
121.
Oh, this one. 11 is 121, 144. Yes. 13?
We are not able to locate your cursor, please.
Pardon?
We are not able to locate. Where is the cursor? We are not able to
13.
locate.
I am at 13.
169.
169.
196.
196 for 14. For 15.
225.
5. For 16.
256.
And for 17.
289.
89. Now, what is the summation of that? What is the summation of that? Yes.
1600.
1600.
1600. So that is our first. That is our first summation of x. So that is the first one.
Excuse me.
You said it is 1600. Then we go to the second one, where we get our other summation of x into bracket squared.
Yes.
The next summation of x is this one here. Have you seen it? The first column. The first column where we have added all the items. We've added all the items, that is summation of x. And we have put the brackets and squared. So 122. 122. 122 squared. Are we there? What do we get? What do we get? 122 squared.
14,884.
14,884.
14,884.
14,884 divided by 10.
14,888.4.
Divided by 10. What do we get?
14,888.4.
14,888.4. 14,888.4. 14,888.4 from 1,600.
111.6. 11.6.
111.6 divided by
9.
Divide by 9. What do we get?
12.4.
12.4 grams squared. Now, that is what I always tell students, that whether you use this formula or you use this other formula, you will always get the same answer. Now, when you realize that you don't have the time to repeat, I know in the exam people don't have the time to repeat that, isn't it? You may not have the time in the exam to do both methods, but I want you to be assured that as long as you have done it correctly, you will get it right. Now, what normally happens where the error occurs is here. The error occurs here. Some students take summation of x sub I, this one here, we have squared it here. They take this one as their first one, and then this other one as their second one. So once you have interchanged, wewe kwisha, right? Are we together? When you interchange, wewe kwisha. But when you substitute appropriately, you will always get the answer correct. So remember, the first summation of x squared is the one where you have squared your x sub I. And then the second one is where you have taken your initial x sub I total, the sum, divide by, you find the square, then you divide by n. And another thing I want you to draw your attention to is whether you use the first formula we used or this one, you go through the same manipulation. This one, you have subtracted first, simplified, and then you go to the answer. Here, you have not simplified, but you will use the same method of having to find the mean. Here, when you do this manipulation here of summation of x squared divided by 10, that is like finding the mean, and you are subtracting the mean from the summation of x sub I, all of it divided by n minus 1. That looks simple as that. So please don't fail a question on the variance. You will always find a question there on the variance. And then here, allow me to put here the appropriate formula. Allow me to put there the correct formula. I don't know where I put it.
And you can't use my own. See when do
We've lost you again.
Ode the doc anaweka formula.
We should be
Natafuta
seeing the
formula
formula.
pe- natafuta formula penye nimeiacha.
Oh,
I
we
have
are not.
put that there was a formula there that was not impressing me, so I was looking for the correct one.
Okay.
Yes. Good. So there I am again. Can now share. I went to look for the formula first before sharing. Share. Share. There I am. So the formula here is simply finding the square root. We are finding the square root. And let me tell you that it is very, very annoying when somebody fails to find the square root. They have worked out very well everything, and then it just comes to finding the square root. Then they just don't find the square root. How? Can I say how or why? Why isn't someone finding the square root? So we have 12.4. So what will be our variance? Not variance, standard deviation. Standard deviation will be I don't know why this thing has gone up. What will be the square root? The square root of 12.4? So standard deviation is the positive square root of the variance and assumes the same units as in variance. It has squared units, for example, meter squared, centimeter squared, grams squared. So what is 12.4 square root?
3.52.
It is
3.52.
3
grams.
0.5,
2.
0.52, the same grams squared. Now, when you have already worked out the variance, please don't go back and start working out again. Haven't you already worked out? So why are you going back to work out again? Because you want to waste time, isn't it? Don't want you to waste time. And the last parameter here is the coefficient of variation, is the standard deviation expressed as a percentage of the arithmetic mean. It expresses sample variability relative to the mean of sample. It is called a measure of relative variability or relative dispersion. So here it is the standard deviation divided by the mean. Standard deviation divided by the mean. What is our standard deviation? Our standard deviation here is 3.52 divided by, what was our mean?
Excuse me, Doc.
Yes.
Under the standard deviation, from
Yes.
the definition, I can see that the unit should be in squared, or
Grams squared, good. Grams squared. Grams squared. Squared. Grams squared. Menweka squared. Yeah, menweka squared, but it looks very small. Yes. What was our mean? 3.5 divided by. What was our mean? 12 point.
12.2. 12.2.
12.2. 12.2. So where have I written 12.2?
Hujaandika bado.
Sijaandika bado. 12.2. I don't know why it's putting for me bold. What do we get?
0.2885.
0.2885.
5.
And
44. Is it?
And
0.28.
if we multiply that by 100 times 100, the symbol multiply is supposed to be on my desktop.
28.85.
I've seen it. Times 100. What do we get?
28.85.
85%. Is anybody has been left behind? Anybody we have left? Hapa nyuma? Good. Now an example for us to work out. An example for us to work out. You're provided with the given data of hemoglobin levels in grams %. Use the data to find mean deviation, range, variance, and coefficient of variation. Can we see the data? Inaonekana? Are you able to see it, or I read it aloud?
Scroll up a little bit.
Okay, I scroll up a little bit. Nyongesa, you are quiet. Sijui kama uko hapa ama uko kwa ofisi.
Niko nafuata.
Lakini usifuate nyuma, enda pamoja nasi. Don't fuata nyuma. Make sure you go with us. I hope my table has all the values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay. Anybody who has finished the mean? Let me give you 10 minutes. This question is just about 6 marks. So don't take more than 10 minutes to work out, because those are just 6 marks. And remember, you have a total of 70 marks.
The mean is 12.1.
12 point?
12.191.
Summation of x over n.
Yes.
What was the summation of x? What was summation of x?
146.3.
Divide by
Divided by 12.
Divided by 12. That is
14.63.
14
Oh.
point. Eh?
14.63 on my end. I don't know.
Oh,
1,
No?
2, 3, 4, 5, 6,
12.19.
7,
12.19.
12.19.
That number should be less than that.
12.19 is the mean.
Yes.
9, 10, 11, 12. N is 12. The values are 12, so the value of n is 12.
Yes,
This
n
guy
is 12.
divided by 10.
12.
Yeah, no, n is
You are
12.
dividing by
Something is
10. It
He's
is
divided
12.
by 10.
N is 12.
Mm.
N is equals to 12.
Yeah.
It's true.
N is 12.
Can't you bring the, excuse me, Daktari, can't you bring the data back?
I bring
Share
it
back
back.
the
Oh, nimetoka kwa screen. Ni best yangu.
I bring the data back so that we see what is happening. Because some people want to lie to us. Good. So screen shared. Screen sharing. Share. Yes. Can we see? To see? Are we able to see?
Yes, we can.
So what is our mean? I've not written.
12.21.
12.21. Can we find the mean deviations?
Mean is 12.19.
19 nilipeana jibu mapema sana na mnaanza kubadilisha answer.
Relax.
It was 12.19 actually.
Actually, the mean is 12.191. We go with that figure, otherwise tutapotea.
It is 12 point?
19. The mean was 12.19.
12.192.
0.192.
2.
You know, you are right to say that we go with the same, because when it comes to calculating deviations, we will all have different values.
Let's make it 12.19.
Okay, that's what I've done. So can we find our deviations from the mean? Our second column.
2.3. I got 2.3.
Work out all of them, we shall bring them together all. We want everyone to work out, and Nyongesa will be the one to give us the values. Nyongesa, you're the one who will give us the values. Nyongesa or Hussein, one of them, because they are just quiet, or Margaret. Margaret, Nyongesa, and Hussein, one of them will give us the values. By the way, what is the range? I've not heard you say the range. What is the range?
4.2.
Highest is 14.
14.4 minus 10.2.
10.2. Okay.
We don't have 10.2, it's 10.5.
But it is here in the data. That means there is a place where we have missed something. It is in the data here, it is there.
The data in the table is not corresponding with the data given.
Yeah, 11.4. The next one is 10.2, and here it's 10.6. Haraka ya mwalimu. So we are different by 0.4.
In fact, in 13.0, it should be 13.6.
13.6.
Should be that, yes.
So now let me change this one up here. So 13.0. This one is 13.0. 13.0. I've changed the one above so that I don't interfere with what we have. I don't know what we used to work out. I've changed the two values there so that we don't change what is in the table. What is the range, Nyongesa? Oh, it has already been said. Let us work out the mean deviations. Sorry, yeah, the deviations from the mean. Msisahau kupewa wagonjwa dawa. I told you the other day that I was training you on not just working, but on speed. So speed must be there. Let me look for Nyongesa to give us the deviations from the mean. Yes, Nyongesa, are you in? We said you don't follow, you tell us. You work out yours.
I mean,
Ronald, are you okay now? Ronald, are you okay? Ulikuwa unalia sauti iko chini.
Yes, madam, I'm okay.
Okay.
Excuse me, Daktari.
Yes.
What did you say about the two figures, 13.0 and 10.6? The two correct value.
I have left the ones which are on the in the table and changed the ones which are up here. I changed the ones. I have retained the ones in the table the way they are. Because I suppose that. What did you use for calculation? These ones or these ones? What did you use for calculation?
The ones above, the data, the original data.
So 13 was 13 point?
No, we used
we
used the one in the table.
We have used the one on the table.
Okay. That is the one I have left.
And
Yes.
I changed the one above to match the table.
Sure.
Yes. And the range has changed.
The range has changed to
3.9.
Okay. Yongesa, can you give us information for our table 2, for our column 2? Yes? Yongesa? Or you didn't carry your calculator? Did you carry your calculator?
Yes, I have.
Okay, tell us. 11.7 minus the mean.
0.492.
92. It's negative 0.49.
Negative.
Positive 0.02.
Positive, the mean is 12.
Somebody has woken up from sleep early. Negative
0.49.
Now, fortunately or unfortunately, you've worked out. I was going to tell you to round up to 2, but now you've already worked out. So this is negative
0.49.
0.49. The next one, Nyongeza.
0.5.
0.51.
5.
1.
1. Naniambia akipotea. Next.
0.01.
0.01. Next.
0.59.
0.5.
0.59.
Nikasikia sauti ya Omondi. Omondi, you are here? Nilikuona
Yes,
kitambo.
I'm here, daktari.
Nilikuona kitambo na ukanyamaza. 13.
1.01.
1.01. 01. Next.
2.21.
The above figure should be negative.
Pardon? They're not negative. These are positive. Negative ones are there. We got that one up there. We'll get another one there.
11.6.
0.81.
11.6 should be negative 0.59.
0.59.
By the way, I
But
made
Dr. you put the bar, so it's absolute.
that is it. I'm
The two
actually
bars.
moving. I've already put the bars for absolute. So 13.0 minus 12.192.
0.81.
0.81. Next, 10.5.
1.69.
Pardon?
1.69.
1.69. 13.8.
1.61.
61. 11.
0.99.
Is it Nyongesa talking or Omondi?
Both.
Or they're the two of them talking. Okay, 10.6.
1.59.
1.59.
59. The next 11.4.
0.79.
0.79.
0.779.
Yes.
Good.
I have a question.
Yes.
You say, are the values subtracted from the mean or the mean from the values?
Pardon?
Are the values subtracted from the mean or the mean from the values?
The mean is subtracted from the values.
Okay.
It is mean from the deviations from the mean. The deviations of each of the items from the mean. How far are the values from the mean? These values we are getting are telling us how far those values are from the mean. Either positive or negative. How far are they from the mean? What is our total here?
11.8.
It is
11.8.
11.8. So we look for our mean deviation. Our mean deviation will be 11.8 divided by divided by what?
12.
12. What do we get? Yes, what do we get? I thought I gave you so much time to work out. Mbona bado, nyongeza bado, mbona bado huja. Oh, ulikuwa bado na work out deviation. Sawa.
0.9833.
0.98.
3.
33 range. We already said what
Getting
range.
9.
Pardon? You're getting
11. 0.99.
Is it the difference in calculators or what?
No, it's 0.983.
Yeah, 0.9833.
The difference is in calculators. So 3.9 was orange.
I think, Doc, from the confusion comes from what you've written there. 11.9 divided by 12 is giving the other value. And if you do 11 by 11.8, now it gives us what the other.
11.8. It was
Yes.
11.8. Sorry.
Yeah, that's where the confusion is.
So where did I get 9? And I'm still writing 9.
I think it's a typo.
Now, what is the answer therefore based on this?
It's 0.983.
So next, we work out the next column. Have we worked out the next column?
Next one.
Squaring. The one of squaring the deviations. Or you want us to use the other route?
Oh, the squaring the deviations. Okay.
We have squared.
We square the deviations or we square the x?
Square
Which
the
one
x.
do you want us? We square the x. Okay. Let's square the x. Have you done it? Have you squared the x?
No, just square each so that we understand better.
136.89.
Have you squared the x?
We squared the third column.
Want to get here
Column.
summation of x squared. X squared
Minus
x squared here. So let's get the values here. 11.7 squared.
136.89.
136.89.
89.
12.7 squared.
161.29.
161.29. Next is 12.2.
148.84.
48.84. 11.6 squared. Where have the ladies gone? Wameenda kufeed watoto na watoto saa hii wajalala.
11.6 squared is 134.56.
34.56.
56. The other one is 174.24.
174.24. The next one?
207.36. 207.36.
7.36.
169.
169.0. 0.0. 10.5.
110.25.
0.25. 13.8.
190.44.
190.44. 11.2.
125.4.
125.44.
Yes.
10.6.
112.36.
12.36. You check on the writings there. Let's not say something different and Malimu here writes different. Yes? 11.4?
129.96.
0.96. Right. Now,
13.4.
what is the total?
1800.63.
1800.63.
1800.6.
63. Now, I want you to work out the next one is variance. I want you to work out the variance using that and that. We now have the values there. So everybody work out the variance now. Using the Bashir formula. Don't use a simple formula. I've seen people are walking away.
In class, Doctor, we've not Tuko.
See, I had 82, now I have 77.
Bundles.
Bundles. I wanted to teach the class yesterday morning when you were at school and people didn't want. So that people use Wi-Fi from the university. Nyongeza, what about that? Isn't that better? Ati mnataka muendelee kulala.
Madaktari walikuwa wamechoka.
Ati wanataka waendelee kulala. Watu wanataka waendelee kulala, wataki kuamka wakuje saa moja for my class. Do you know why I don't like this evening classes? Students complain. Huyu mama hata hataki kumaliza aende anaendelea tu. Sometimes the students were talking like that. Sema oh. Sasa hiyo class hata wakaanguka wakaanza kulia. They were complaining like their patients. They were even worse than their patients. Hata nyinyi mnalialianga nyinyi pharmacists. Mnalialianga kama hao wengine.
Sisi hatuliangi.
Hapana daktari.
Oh, my own nurses wanapenda kulialia tu kama wana patients wao. Lakini sio nurses regular. Nurses regular they are very good. Lakini nurses hao wenye wako practicing, upgrading. Hey. Penda kulialia.
Shida.
But the last class I had was very good. It had a very good class rep. Even if he doesn't come to class, he just says, Daktari, we are very good. Sisi huwa tunajituma. Sisi ni wazuri. And he doesn't come to class. You would rather have such a positive person than those who are ever crying. Hata kuwafunza wanataka walie. Mtihani walie. Time hawajapewa ya kutosha. Na sasa mimi nimewapa time mingi sana. Now it's me who is spoiling you because in the exam you won't do these things for all these minutes. How many people have got the answer? Sasa andika hiyo formula hapa. Let me bring it down. Nyongeza Huseni alitoka mosque. Ama leo anakesha? Leo anakesha kwa mosque. Takutana tu nitamuuliza kama huko pia alikesha. Right. Let us substitute I see.
Tuko na 1.453.
1.253.
Yeah.
Okay. What was your first summation of x?
15.99.
And then
15.99.
Some 100
Yes.
and
Hii ni x squared kama nataka kusema.
Haizi kwa x squared because we're using the expert way.
146.3 squared divide by n. Ukapata nini hapo? 1800 minus. Hiyo ukapata nini? Summation of x.
17.64.
Pardon?
1783.64.
1783.64. What do you get there? Subtract unapata?
Ma. 16.989.
16.9. Sorry. 989 divide by
11.
Divide by. Unajua mwalimu vile anasikianga vibaya anakuona wewe uja divide by 11 ume divide by 12. It's very bad. Yes?
Natupatia 1.5445.
1.5 4,
5.
4, 5.
Mm.
Now, I want you to look at the difference between the data in the second table and the data in the first table. You remember the first table, how the data was sparsely, the range between the first and the last was very high. And look at the range this time, and then look at the variance. That is what we are talking about, right? And then now, what is the standard deviation? Standard deviation. What will be the standard deviation? That's the square root of 1.54445. What is the square root? Yes? Oh, nimeiona.
It gives us 1.2428.
Long. So now from there, we can work out our coefficient of variation. Can work out our coefficient of variation. That is 1.24 divided by 12.19. That gives us 0.101. Percentage will be 10.2. Good. I am not going beyond there. Anybody with a concern, a question? Nyongeza, are you okay? Nyongeza, uko sawa?
Yes.
Margaret, uko sawa? Sawa. Odede, uko sawa?
No, I got lost at the second point.
Angela, uko sawa? Angela, uko sawa? Eh?
Yes, I'm fine. I'm fine.
Anyango?
I'm okay.
Ronald, uko sawa? What about Catherine? Catherine, uko sawa? Eh?
Niko sawa.
Hey, tuko sawa?
Yes, I'm okay, Doc.
Edwin?
Doc.
Edwin?
Yes, daktari, I'm okay. Yes.
Vincent yako sawa. Si Vincent wewe umesema uko sawa?
Niko sawa daktari.
Hata Ronald amesema uko sawa. Angela amesema uko sawa. Caroline sijui kama uko sawa. Good. Good. Yongesa, next time you plan for a makeup, you plan properly. Now I know in my attendance I have missed some students. Some students were coming in and out. But at least I captured around 82 students. So thank you so much for coming. You've done well. Now I have missed around 40 students. Yes, Shadrach.
Thank you so much, Doc. I'm requesting if you wouldn't mind to send us these notes
For today.
Yes.
Nitawaletea hard copy Daro next week.
Unaweza polish up. Okay, sawa, asante.
Ama niongeza akinikumbusha. I have a hard copy. I think I have a hard copy in school.
Oh, okay.
I will bring it.
Okay.
I'll bring it. Sawa. Have a good
Asante.
evening, everyone. Thank you so much for making it.
Thank you so much, Doc.
Thank you.